or they're used in a function. So think of it like this. Can you use something that you don't have? You can't. That's why with variables, you can only use a variable that you've already declared and defined. So there are multiple ways you could declare a variable. One way is the data type followed by the name you want for your variable, followed by either a value and or an expression. So what does that look like? That could be something like integer x equals 0, or it could look like double y is equal to 2.2 times 3.3. Both of these are valid variable declarations because they follow the format of a data type followed by a name followed by either a value or an expression. Any questions about identifiers, variables at this point? No? All right. So another thing to point out about C is the fact that it's case sensitive. So earlier we talked about identifiers, which helps us find our variables. So when you have identified your variable, once you've declared it, the way you typed it is the way that you should continue to use it throughout the program. So it's important to keep in mind, but if you use uppercase, anytime you refer to that variable, you have to spell it the same way, because C will treat it as a different variable if it's spelled differently, if it has different cases. So here you see this example comparing main to main. Traditionally, main is all undercase letters. So if you were to use main with a capital M, C would treat it as a whole new function. You might think it's the function you might want to use, but always be mindful of how you wrote your variables, because that affects whether or not you can use it in the rest of your program. So, as we mentioned earlier with the identifying of a variable, variables have to have a name and a data type. So, what data types do we know of? We have integers, we have characters, floats, doubles, longs, shorts. So when you're thinking about a variable and you're trying to figure out what type to use, you should just ask yourself a few questions such as, what am I trying to represent? What are the values that I'm working with? And that will give you a clue as to what variable type to use. So the English alphabet is comprised of letters. Conveniently, we have a data type just for letters, and that's chars. Additionally, we have doubles. Doubles, as we know of, have a decimal point, so we can use doubles anytime we need to deal with fractional amounts or decimal points. So let's take a look at some of these do's and don'ts when dealing with variables. So it's very easy to write variables like x, y, a, b, c. It's very easy to write it like that, but it's more useful to have variables with descriptive names, names that let you know what that variable is being used for. Not only does this help you understand your code personally, it also helps others who look at your code understand what's supposed to go on. You can declare multiple variables on the same line. So I have integer x equals 0. If I wanted to add more variables to that line, I would just separate them by commas, and that way you can declare multiple variables all on the same line. So there is a format to use when naming your variables, and for the most part, you want to avoid starting a variable name with a number. You want to avoid starting your variable name with an underscore. And you want to avoid using key terms. So what are key terms? Easy way to remember key terms is if you're using a compiler, key terms tend to be blue. Otherwise, another way to keep in mind are the functions that you use tend to be key terms. Main is a key term, printf, for, switch. These are all key terms that you should avoid using as a variable name. Now, going back to what we were talking about with data types, we have enumerations. Now, enumerations is a data type that you can define yourself. An example is what you see here as using an enumeration to represent the days of the week. Now, enumerations will assign a value to each of these words. The usefulness of an enumeration is that instead of just having a value, you have a word that has more meaning. So meaningful words is very important when you're programming. One more thing to keep in mind about the variables that you use is how much space that they take up. So a character, single byte, takes up less room than an integer, for example. So keep in mind that some of your variables store more or less depending on the size, which is why we have long, because the size of an integer can only hold a certain amount of numbers. So if we want bigger numbers, we tend to use long to represent those bigger numbers because long has more space in the memory for that value. All right, so a statement. Every statement you can consider a sentence in programming. So a statement ends in a semicolon and is read in order as you would a normal paragraph. An example of this is both of these variable declarations. And we know that they're statements because they both end with a semicolon. Now before, I said you could declare a variable using either a value or an expression. Do we know the difference between an expression and an equation? Well, very easy to differentiate the two, and that is an equation has an equal sign in it, and an expression doesn't need an equal sign. So A times B plus C is an expression, whereas if I were to say y equals A times B plus C, now that is an equation. You might think to yourself that this is an equation. It is, but the part that makes it an expression, we're only going to be looking at this part. This is what we call an expression. It's just a set of terms and operations that ultimately give us a value. So let's talk about the operations then that we have to use. There's a few of them. So big thing that you're going to notice when you program in C is the fact that division doesn't work the way that division works in traditional math. So with Intro to C, when we divide a number, we're performing integer division, which means we're not getting any decimals in our answer. So for example, 3 divided by 2 we know as 1.5, but in program, it would only read that as a 1. There are benefits and disadvantages to having it function that way, but it's important to know that when you do integer division that you won't get a decimal place. Now, if you decided you do need a decimal place, then we can look back at our other data types such as floats and doubles. There we can use division the way that we traditionally understand it. Useful operation is the percent, aka the modulus operation. So do we know what the modulus does for us in code? Excellent. So it gives the remainder. So you can think of the modulus as a pair to go along with the integer division. So if we were to divide 3 into 2, we would get 1. If we did long division, we'd know that we'd have a remainder of 1. So what the modulus does is it gives us that remainder from an integer division equation. So if instead we had 3 modulus 2, we'd also get 1. but 1 is the remainder in that case. What other ways is modulus useful for? Well, because we know that it gives us a remainder, we can use that information to calculate all sorts of things. One thing you can use modulus to calculate is whether or not a number is even or odd. So how do we use modulus to figure out whether or not a number is even or odd? Well, a number that's even, when you divide it by 2, there shouldn't be a remainder. So when you modulus any number by 2, whether or not it gives you 0 or 1 will tell you if it's even or odd. All right, so very similar to the mathematics that we're used to. The operations in C have an order to them. So we have parentheses, we have our increment, decrement assignments, aka postfix and prefix, and we have expressions. So I want you to keep in mind the order of operations in your C code, which affects how statements are evaluated. All right, so let's move on then to equalities and relations. So where do we need equalities and relations?
Depends if you're assigning a value or you are calculating a value.
Excellent. Yeah, it's very situational where we need them, and we should know what they evaluate to. So we think of it as true and false, whether or not this statement is true or false. But in C, true and false isn't represented with just the words themselves. True and false has a value. So it's important to keep in mind that 0 is considered false, and anything that's not 0 is considered true. So if you were to put a 0 as your condition for an if statement, that condition would be read as false. Any other value would be read as true. So let's take a look here then at this code example. Is this too small? Should I increase it? Good? All right. So this is just an example of the prefix postfix that we were taking a look at earlier. So initially we have x and y, x set to 0, y set to 1. So if we were to perform these operations, y plus plus, x minus minus, what are the values we expect to be stored in x and y now? Well, y plus plus would give us y equals 2, and x minus minus will give us x minus 2. Or x minus 1, I should say. So one thing to keep in mind about prefix, postfix is in the end, they both will either increment or decrement your variable. What's different is in the process. So if you were to print out, so keeping along with x is equal to 0, if I were to printf x plus plus, what value do we expect to see in our output? Yeah. Excellent guess. It's not 1, unfortunately. So this is something that's very particular about prefix and postfix, and use the name to help you realize what's happening. So this is an example of a postfix, something that happens after. So when we're printing it out, once the compiler gets to this x, it reads the value of 0. And it's after it reads the value of 0 that it gives us the plus plus, which changes the value of x. So if I were to go back in, I'm just going to shorthand this and say print x. After this line, we would see that x is equal to 1. If I were to swap this and have plus plus x, this is a prefix. So this would happen before we use the value of x. So in that case, x would have the value of 1 when we print it out. So always look at the order of your operations, and keep in mind that with prefix and postfix, whatever happens on that line depends on whether or not it is in front or after the variable. So just keep that in mind when thinking about prefix and postfix. All right, so let's get into a little discussion about program structure. So for the most part, all the programs you write is an algorithm. Now, algorithms are useful because they provide us with a method of solving a problem. They describe how we will solve that problem and the steps we need to take to solve that problem. So think about multiplication, for example. We know the multiplication table because they drilled it into us. But there's a step that you take to multiply numbers. So 5 times 3 is traditionally 5 plus 5 plus 5. So multiplication in itself is an algorithm that uses addition. This is also considered an algorithm. It is just an algorithm that prints out x. So it's a very simple algorithm. But the more complex the problem you want to solve, the more complex the algorithm tends to be to solve it, which is why getting good program design is a good step towards achieving that algorithm. So how do you design a good program? Well, the first step is planning. Planning your code is going to help you a lot when you're writing it. And one way you can plan your code is using a flowchart. So a flowchart will help you visualize how you go from step to step. It will also show you where you might be able to improve your algorithm or where you might be having issues in your algorithm. So it's a good tip to, if you're a visual learner, use flowcharts before you code so that you have a mental image of what you're trying to do. Now, you could also use pseudocode. So pseudocode is not code itself, but is written in a way that makes translating it to code easier. So why use pseudocode to plan your program? Well, maybe you're not the most technical in a certain step in your algorithm, and you're not sure how you want to go about doing it. That shouldn't stop you from programming. You can write pseudocode as a sort of placeholder. You can say, I want to do this with X, so I can use it to do this, so I can use it to do that. Just writing that out in pseudocode is going to help you formulate a strategy into how you can get it to do it the way you want it to. And as an example, this pseudocode is a sentence, and it says, if a student's grade is greater than or equal to 60, I want you to print pass. Now, this pseudocode is very easily translatable to actual code. We have if, we have a relation that we want to check, and we have an outcome that we want to produce. So use this when you're coding to outline in your file what you want your code to do. These are tips to help you write more well-designed programs. Section. All right. So at its base, without anything happening to your program is run sequentially. So that means every line is executed, followed by the next line, followed by the next line. So like with this code example here, these lines are executed in order. It's important to keep in mind. Now, you don't always have to execute your program in order, so that's what we have selection for. So selection offers a way of choosing a path for your program to follow. So what selections operations do we have available to us? Well, we have the if-else statement. So either it's true and we try it this way, or it's false and we try it another way. In addition to the if-else, we also have the ternary operator. One of my favorite selections is simply question mark colon. So do we know how to use the ternary operator for selection? All right, let me show you guys a quick example of how to use that. So I'm going to show it to you side by side with an if-else statement so you can see the comparison. So if passed, I will say, then hooray. I don't know if I spelled hooray correctly, but else, we're going to print out a sad face. All right, so this is our if-else, and I'm going to show you how to convert this if-else to a ternary version. So with the ternary operator, the very first thing you want to write is your relation. So that relation is passed. And then after you write passed, you write the question mark. This part is what you want to happen when your condition is true. Then you have a colon. And this part is what you want to happen when the condition is false. So hurrah or hooray, and then sad face. And I'll end this with a semicolon. So why use the ternary operator instead of an if-else statement? Personally, they will do the exact same thing for you. Why would I choose one over the other? Sometimes you don't need to have all of this written out to get your selection to work the way you want it to. So if you have a small set of statements, you can use the ternary operator, do it all in one line, makes it look nice. But if you have multiple statements, multiple conditions, it'd be easier to just use a traditional if and else, because the ternary can get really confusing the more levels you have to it. And what I mean by levels is, let's say, for example, you had an if inside of an if. We can see that a lot easier than having a ternary inside of a ternary, which would be a very long line and not always easily read. Okay. So in addition to sequence and selection, we also have repetition. So why do we need repetition in our code? One reason is we don't want to write the same statements over and over again to do something multiple times. You could, and for some situations, you could simply write 3 or 4 statements that do the exact same thing. The issue arises when you want to do something hundreds of times, thousands of times. For those situations, we want to use loops. And to use loops, we need to know a few things. We want to know how many times we want it to loop. We want to know what kind of looping mechanism we want to use. So we have for loops, we have while loops, and we have do while loops. So depending on the situation, you will choose one of these 3 loops to accomplish your goal. Let's see. All right, so let's talk a little bit then about functions and the reasons we use functions in our programs. So imagine you're creating an algorithm where there are a series of steps that lead into each other. You can write this algorithm all in one line, or I should say all in one file, and it will work the way you want it to. Sometimes, though, that algorithm is complex and has a lot of parts to it. So to help you understand what's happening, you want to modularize it or create functions to handle subtasks that are part of a larger goal. This will make your code easier to debug because an error will only occur in a small part of your program. It will make it easier to use in other applications because once you've written the function, you know how it works and you can use it for different purposes. And also, if in the future you did need to go back and make changes to your algorithm, because you had a modularized program, it would only be a small part, again, that you would have to fix. And functions, they could be those small parts of your code. So it's a very good strategy that if you have a task to do, to write a function to accomplish it for you, not only does that make your code easier to read, it also makes it easier to debug. So now that we're talking about functions, let's see how we write functions. All right, so functions have a definition and a prototype. So what the prototype is the blueprint really for your program, for your program's function. Now that blueprint should have these parts to it. It should have a return type, it should have a function name, a parameter list, and a semicolon. So let me write that down. All right. So, return type, followed by a function name, and your parameters, semicolon. Now that's your prototype. And the reason you want a prototype in your program is when you look at the very top of your program where prototypes tend to be placed, it gives you an idea of the functionality of your code, what you can do, how to do it. You could just read a prototype fairly quickly and know what it's supposed to do. Now, knowing what it does plays a role in how well you name your function. So before, when we talked about identifiers, functions, their name should also be descriptive, telling you what they do. For example, find slope, get file. You want descriptive words that let you know what your function is doing, so when you use it, you have an idea of what to expect. So along the lines of the return type, your function can either return something to you, or it could return nothing to you. So that would be a void. A void return type means your function doesn't give you anything back. If you did want it to give you something back, you'd have to decide what it is, the type that you want it to give back to you, whether that's an integer or a character. You could accomplish a successful function regardless of it gives you something back or not. It's up to you to realize which one you want to use. All right. So do we know the difference between the parameter of a function and the argument of a function? Yes? Excellent. Yeah. Close. So you're correct. The parameter is what you're telling your function that you're going to use. So the argument, so along the lines of fun name, the argument is actually what you pass when you call your function. So the parameters is telling the function what to expect. The argument is actually what you're giving it. All right. Any questions so far? Good. All right. So let's continue then. All right. So there are cases where we need some randomness in our program, and in order to accomplish that, we need some sort of mechanism to give us random values. Now, we have the rand function. Rand function gives us a random value. It gives us a value between 0 and a maximum random value that the computer predetermines. This is fine for most applications, but let's say you want to have a random number in a certain range. So in order to have a number in a certain range, we need a formula using rand to calculate this. So if you don't already have this, this is a very useful formula for calculating a number in a given range. So if I wanted to calculate a random number between 20 and 30, how would I accomplish that? Well, you can use this formula. So if my range is 20 to 30, I will just replace everywhere that says min with 20, and I'll replace everywhere that says max with 30. And if I do this, my final formula will be 20 plus rand modulus 30 minus 20 plus 1, which is 11. So that's how you would generate a random number between 20 and 30. So let me ask you a little bit about the math behind it. Why is it that we use the modulus in this case? It is the remainder. So here's a little fun fact about modulus. It always gives you a value in the range of 0 to 1 minus the number you're doing the modulus of. So for example, for 11, the values that we could possibly get as a remainder is 0 through 10. That's useful to us because if we were to take a random value, 0 to 10, and add it to 20, ultimately we get a random value that's 20 to 30. Because we're either adding 0, we're either adding 1, all the way up to 10 to our 20. So that's the math behind this formula, why it works the way it does. Sometimes you will notice that even though you're using a random function, such as rand, to generate random numbers, you keep getting the same set of random numbers. So even though the list itself is random, it's not truly random. So in order to make sure that you can have even more randomness in your random function, there's an additional function called sran. So with sran, we set the seed of our random function. So the seed is used in the calculation of the random number, and this function helps you set the seed so that you get a different sequence of random numbers. So any questions on random, the formula, and where you can use random? So where might you want to use a random number? What might that be useful for you? Yeah. Rolling a dice, classic example. If you wanted your program to roll a dice, we'd want it to roll us a random value between 1 and 6. Another way to think about a random number generator is you can think of it as a lottery. You can generate a sequence of random numbers and try to find a match. That's similar to how the lottery works. I've never won, so I can't really tell you, but let's continue then. All right. Control +++. So let's talk a little bit then about the variables and how they are stored and used in your program. Yes?
Does SRAN have the same formula as RAN?
So SRAN itself, its purpose is to set a seed. So all you do when you use SRAN is you call SRAN with a value as the argument, and it will change how random generates its number. So you don't need a formula to use SRAN. You simply call it with a value that you wanted to set the seed with.
So how would you do that if you roll a die?
So rolling a die, you don't need to change the seed for, but let's say you're generating 1,000 random numbers, right? You generate 1,000 random numbers, you generate 1,000 random numbers. If you're both using the same seed, you will get the exact same sequence of numbers, which doesn't make it all that random. But if you were both using a different seed, your list of 1,000 numbers would be different. So that's why you use the seed, is if you want the sequence of random numbers to be different. That's what SRAN will change, is the numbers that it produces. Yes?
So is SRAM for like larger data sets as opposed to HRAM being for smaller data sets?
Good question. I would just say that SRAN is useful for making sure you make your random as truly random as possible. When you're dealing with a range of values, SRAN isn't all that useful. But then again, it all depends on your application and whether or not it matters to you that the first 20 random numbers are always the same. If you're writing a short code, maybe that won't be too much of an issue, but you do have the option of making it change that sequence. So you always have options with programming. All right, so let's take a look then at variables and how they're stored. So there are a few types in this storage class of variables. One of the first types is the auto type. So the auto type is one of the most convenient ones. You don't even have to write it because it's automatic. So all the automatic type states is that your variable is local to the block that it exists in. So a block is anything in between two braces. So if we had a variable declared in between two braces, that variable would automatically get the auto storage class associated with it. So we also have the static storage. So with static, does anyone know why we use static or how we could use static? Yeah. Excellent, yeah. So when you run your code and it finishes, whatever values that were in your variables, they disappear. But what if you wanted that value to stay there? If you use the static storage class, then whatever you do to that variable will stay with that variable. So if you make a change in one function, that change will stay throughout the program. Now, we talked a little bit about how the auto storage class puts your variable in the scope of the block that it's in. What if you wanted to use a variable outside of the block that it's defined in? If you use the extern storage class, that would allow you to access that variable outside of that block. So here's a few situations where that might be useful. Let's say you're writing multiple files with multiple variables. Instead of recreating those variables for each file, you can have them declared as extern, which means they'd be available anywhere in your program. The usefulness of that is you can put all your important variables, all your important functions in one place, have them set as extern, and use them everywhere else. So extern has a useful application in a sense that it can extend where you can use a variable. So it's similar to global. The difference between extern and global is a global will make your variable available anywhere within that same file. Extern lets you use that variable even if it's in a different file. So we can use header files, for example, to define a set of functions that our program might need to use. You can also define variables in your header file. So if you made those extern, they'd be available to all your C files that might need it. Whereas if it were a global, it would only be useful in that file. Any questions on the storage classes? All right. So as I was mentioning earlier, variables, their use is dictated by the scope that they exist in. So what is the scope of a variable? Scope is simply where you have access, whether that's inside of a function, if that's inside of a block, or that's inside of a file itself. Scope changes depending on how you define your variable. So it's important to keep in mind what the scope of your variable is that you need to use, because that would either allow you to access it or not allow you to access it. And as we're saying with global and external variables, their scope is the widest that you could have for a variable. They can be used nearly everywhere throughout your program. But otherwise, you have to be mindful. If I had a variable x inside of my function, then x could only be used inside of that function and wouldn't be able to be accessed anywhere else. And also, as I mentioned earlier, the most basic scope you will see a variable declared in is block scope. So in between two braces is how we will define scope for most variables. So a quick way to know the scope of your variable is find the braces that contain it, and that will give you a general idea of where it can be used in. All right. So how many people in here love recursion? Recursion. Oh yeah? See, recursion is amazing. It's a different sort of approach to solving a problem. So what makes recursion unique is it's a function that calls itself. Why is that useful? Well, there are certain problems that can only be solved recursively. Very good example of a recursive problem is a factorial. So do we know the definition of a factorial? Yeah, so 5 factorial is how much? It's times, yes. But look at the formula. It's 5 times 4 times 3 times 2 times 1. Another way to think about it, how I thought about factorial using recursion, is in 2 parts. So first, I saw that 5 factorial is equal to 5 times 4 times 3 times 2. Technically, you can stop at 2, but I'll put the 1 as well. But take a look at this sequence. If you notice that this part right here is 4 factorial, then you're well on your way to seeing how recursion can solve this problem for us. So if 5 factorial is in fact 5 times 4 factorial, then what we see here is that our solution needs the same function that we're trying to solve. So let's expand this then. 4 factorial is in fact 4 times 3 factorial, and so on. 3 factorial is 3 times 2 factorial. So how do we translate that into recursion? Well, the 2 parts a recursion function will always have is a base case and the steps you take to reach that base case. So how do you find the base case? You think of the most simplest problem that you're trying to solve, and that would be your base case. So for something like factorials, the most simple factorial you can do is 1 factorial, and 1 factorial is simply 1. So in this code segment, we see that our base case is 1. We return 1 whenever our function gets called with 1. Otherwise, as I showed you, we have to take steps to reach that base case. So the step I took was that I said that our number, factorial, is equal to that same number, but multiplied by the factorial of 1 less. So what that looks like in code is return the number we want the factorial of multiplied by 1 minus the factorial of that number. So as this program calls itself, we will see it ultimately give us the answer that we need. Does anyone want to see me go through the recursion for factorial? Yeah? Sure. All right. So keep this code in mind as I go through an example. I will do it with 4 so that it doesn't take as long, but let's let's call 4 factorial. So let's call factorial of 4. So when we call the factorial of 4, when we reach that first if, do we meet the conditions for that first if? No. So for the very first time, we go into the else, so we get return 4 times the factorial of 3. All right? So now the program tries to solve for the factorial of 3. Again, the factorial of 3 doesn't meet the base case that we're trying to solve. So for factorial of 3, we get return 3 times the factorial of 2. Once again, 2 doesn't meet the base case that we want for factorial, so we have to go one more level, and that's return 2 times the factorial of 1. So in this step, we actually reached the base case of our factorial, and now you can sort of trace back your steps to find your ultimate solution. So the factorial of 1 is 1, so 1 times 2 gives us 2. So we jump back with a value of 2. So now we have to return 3 times 2, which is the value we got back from this recursive call, which is 6. So now we jump back one more time with the value of 6. Now we have to return 4 times the value of 6, which is 24. So on our last jump, we get the value of 24. So at every step, you see how we needed to call the function again, but with a different value, and ultimately, the program traces itself back up to when it was first called. Something to keep in mind about recursion is what you're seeing here. So you see how we're stacking these function calls one on top of each other? That's what happens in the program itself. All these functions get placed on the stack. A danger of using recursion is a problem you might be solving might call itself too many times, and you overflow the stack. You have too many function calls, and your recursion problem breaks. So something to keep in mind when writing a recursive function is A, it has a base case. B, you have to find a way of getting your current problem closer to that base case, which is what happens in this else. We're getting closer to our base case. And 3, if your recursive function calls itself too many times, you run the risk of overflowing the stack. How do we feel about recursion? Are we familiar with, let's see, how should I say this? Fibonacci. So Fibonacci is another very famous problem that you can solve recursively. So let me ask you then, what would be the base case for Fibonacci? What is the smallest set that you can have in Fibonacci? 1. So for a Fibonacci recursive solution, one of our base cases will be 1. So to refresh, Fibonacci is a sequence of numbers that goes a little something like this: 1, 1, 2, 3, 5, 8. So the way it's defined is, at least after the second number, the third number is the sum of the previous 2 numbers. So every number is always the sum of the previous 2. So if you want to think about a recursive solution for Fibonacci, one way you reach the base case is, for example, if we had Fibonacci of 8, Fibonacci of 8 should somehow give to us 3 and 5. So how do we think of this? If you numbered these as 1, 2, 3, 4, 5, 6. If we wanted the 6th Fibonacci number, we would then need to calculate the 5th and the 4th. So instead of saying return n times factorial of n minus 1, we would say return Fibonacci of n minus 1 and Fibonacci of n minus 2. And very similarly to this factorial, it will add these numbers up and eventually give you the correct Fibonacci number. I will show you guys the code for Fibonacci after we get through more of this content. So how do we feel right now about the review? Are you getting what you'd like to get out of it? Should I do something different? Good? All right, excellent. So let's talk a little bit then about what happens before your program does anything for you. So that happens in the pre-processing. So there are steps to your program doing what it does for you. There's a pre-processing step that takes place. There's the actual compiling and then the execution of your code. So before anything, your program first looks at the pre-processor directives. One of the directives that we're all familiar with is include. We use include so that we have access to the standard library, so stdlib.h. We use it to have access to the math library, so math.h. So anytime you're using hashtag or pound include, you're telling the computer to link to another file that has functions that are useful to you. Another useful directive that can happen that you can use is define. And with define, you can simply just say, this is something I want to have, and I want it to be available to me throughout the program. Why might you define something versus creating a variable for it? Yeah. If you define something at the very top of your program, and if you use that definition, all you'd have to do is change the value of your definition, and it will change it everywhere. Common way to use this is, for example, in a for loop. So in a for loop, we have to give it a few things: where to start, where to end, and a condition to reach that ending. So if you made that condition, for example, while x is less than 100, if you made it while x is less than loop size, where loop size is defined, anytime you change the value of loop size, that changes how your loop works, which is useful because one change has a big impact. Yes? You could just as easily use a constant. Yeah, they will function very similarly. One difference between defining and using a constant variable is that you can define more than just a value. You can sort of define functions using define. You can use macros, for example. That's another useful thing you can define. You can define a macro as being define area of circle. Area of circle is pi r squared. Am I correct? Yeah, so you can define pi r squared as a macro, and anytime you call that macro, it will sort of function as a function. So you could use a constant. The applications are a little different, but just know that you have define available to you. And to complement define, we have undefined, right? Why might you undefine something? Yeah. I see what you mean. That's not really how undefined works, but that's close to how free works. We'll get to memory allocation, but remember how you can define like a constant? Let's say we define pi. Excellent way for me to show this to you is to think about the universe. Let's say we're in universe A, and we define pi to be 3.141529. That's about all I know for pi. But this is our definition of pi. We can use it in all sorts of different ways. But let's say somewhere along the line being your program, you enter universe B. Now in universe B, you want pi to be a different value. But because you define pi like this in universe A, the only way to redefine it is to first undefine it. So we undefine P, and then we can redefine it. Now in this universe, pi is simply 3.14. So this is why you use undefined, is maybe later along the line you want to change your definition. Yes?
So like this, from the top, you would define it, up high as P.
Yeah.
And then further down in your code,
Mm-hmm.
the same file.
Yeah.
If you want to change it,
Yes.
you undefine it and then redefine it.
Excellent. Yeah. So you can use one definition for one part of your code and use a different definition in a different part of your code. It's very similar to changing the value of a variable throughout your code, but with the power of it being a definition. All right. Arrays. What do we know about arrays? Well, an array is a way of putting a whole bunch of values together. You can think of an array, I always think of an array as like a train, where every car holds some value for you. And the train itself is your array. So an array has a format to defining it. An array has to have a type. What does that mean? That means your train needs to know what its cargo is going to be. It also has to have a name, whether that's, let's see, Tri-Rail or Sunrail, I believe is another one. That would be the name of your array, and the size of your array, whether that's 1 to a billion. You want to define how big your array is going to be. So arrays, their name is very similar to a variable in the sense that it can't start with a number and it can't start with an underscore. So if you follow the same convention for variables, you can also name your arrays correctly. So here's a question. Let's say I have an array of 50 elements. How do I access the 50th element? What was that? I see what your point is. So saying if it was, so this would be the 50th spot, and this would be the 51st spot? Or am I miss?
Well, like, I guess I was just trying to say, like, there's a little character at the end, so it's whatever.
Oh, yes, yes. Let's not talk about strings just yet, just arrays in general. My point is that when you're accessing an element of an array, you need to know where in an array you want to look. So thing to keep in mind with arrays is the fact that the elements, they start at 0. So traditionally, we like to count from 1, but arrays, they like to count from 0. So if I had an array that had 50 elements in it, the last element is actually element 49. So that's something I wanted you to just remember, is when you're accessing an array, the values go 0 to 1 minus the size of that array. All right, so how do we loop through arrays? How would you loop through an array? Yeah. For loop? How else might we loop through arrays? We could also use while loops. We could also use pointers. You have a lot of options for looping through an array. Let's take a look at multi-scripted arrays. So what we have here is just an array of one dimension. You can think of it as just a line of values. But there are cases where you want to have multiple lines of values, sort of like a grid. All right, so think of a two-dimensional array as a grid, where we go from 0 to the n minus 1 here, and we go from 0 to the n minus 1 there. All right, so something to keep in mind about a two-dimensional array is the order that you access the elements. So we think of arrays in two dimension as being row-column order. What does that mean? That means if you want to find an element in your array, you first need to know the row that it's in, then the column. So let me give our two-dimensional array some values so that we can see what I mean. So let's just say that we go 0, 1, 2, 3, 0, 1, 2, 3, 4. So it's row, then the column. So if I wanted to access this element, what would my values be for the array? 3 then 2, yes. So it's always row column. It's very easy to like mix them up and do 2, 3, but 2, 3 is a very different spot. So always remember that when you're creating your array, you should always think of it in this format, going top down for the row and going left, right for the column. And that should help you always access your array correctly. Now, are there any questions about arrays themselves? No? All right. So let's look then at some applications of arrays, and that's in sorting techniques. Are we familiar with bubble sort and how that works with numbers? Yes, no. Let me see if I can help you guys a little bit. Bubble sort is, all right. Bubble sort is a way of sorting an array of values such that all the elements are in order. And it does it in this way. It starts with a list of numbers, and every time it approaches a number, it compares it to the next number. And using that comparison, it decides whether or not it wants to swap that number out. So if we had a list of, let's say, 3, 1, 8, 7, 6, the very first step of bubble sort would be to start at the first number and compare it to the next one. So in this case, we see 3 is in fact greater than 1. So what bubble sort does is it swaps the 3 and the 1. Now we're at this step. Is 3 greater than 8? No, so it does nothing. Then we look at 8. Is 8 greater than 7? If so, we swap them. So now we have 3, 7, 8. It should be a 6. So in this way, it goes through the list of numbers, swapping values until ultimately the list is sorted. Yes?
Is it like, do you use it for any kind of list and try to order it in any way you want?
Yeah, the general format of bubble sort is you can apply it to any data type, really. It's a strategy. You can use it on integers to sort a list of numbers. You can use it on characters to sort a list of characters. You can even use it to sort a list of structs. What changes is how you do your comparison. So in this case, Is this readable? Should I? Okay, excellent. So in this case, all we're doing is a simple greater than or equal to comparison between numbers. If you were doing it with, let's say, names, the comparison between names is a little bit more involved, but the same strategy will be used to do the comparison. So I'm just going to go through this bubble sort example one more time. So for this program, I randomly generated a list of numbers, and then I tried using bubble sort to sort them. So in round one, what do we see happen? In round one, we see that the 18 gets swapped all the way to the end. In round two, we see that the 16 gets swapped all the way to the end. How does this work? Is bubble sort functions in rounds. So each round, it's looping through your array and finding the largest number and putting it at the end. So every round, the number that gets put to the end is the largest, then the second largest, then the third largest, and so on and so forth. So eventually, you reach the last round, and your list is sorted. So if you want to take a look at this code, it is available in the document that I've posted on the WordPress website. So you can easily go take a look at the code if you want to maybe use it for your own applications or just get a better understanding for it. So let me get back to, nope, that's not it. Bubble sort. All right. All right. So we've pretty much reached the end of the notes that I have for just the introductory of Intro to C. But are there any general questions about programming that you have right now, or would you like to practice some problems? All right. So if you have your computer, feel free to use that to practice the problem, but I'll also be going about it myself up here, so you can pay attention to me, or you can attempt it yourself. But either way, let's take a look at some of these problems. So this question directly relates to what we were talking about earlier, but which one of these values is considered true? So let's zoom in. So for question one, A through D, which one of these values is true? I heard something. All of them, yeah. So anything that's not 0 is true. That could be 1, 66, 0.1, -1. As long as it's not 0, it'll be considered true for your program. This is weird. It goes 1, then 3. But besides that, what is the value that this line will give to us with the fact that 0 is false and 1 is true in mind? So I'll give you guys a minute, see if you can come up with the solution. But I will go through it and we'll see. So we have a pretty complicated looking relation. The way I'd say to tackle this problem would be to start with the innermost relation and evaluate that and work your way outwards. So if we look at the most inner relation, that is 0 or 1. So if we had 0 or 1, what value would we get back from it? Remember, 0 is false and 1 is true. So if we had false or true, what do we get out of that relation? True. So this innermost part evaluates to true. All right. but then we see that there's a exclamation point in front of that. So that exclamation point means the reverse of whatever value it's operating on. So if the reverse of true is false, this whole piece here ultimately gives us false. So what happens if we took a true and it with a false? We get a false. True and false combined together in this way gives us false. And then ultimately, we have a exclamation point, so that false becomes a true, and at the end of the day, this whole line evaluates to true. Very convoluted, but it's a great example of how your program evaluates complicated expressions. So we talked a little bit earlier about functions, but which of these functions is complete? Which is the most complete function on this list? So remember, functions have a return type, a function name, a list of parameters, and a body. B. A is not a function. It's not a complete function. It's merely a prototype. B is the most complete because it does follow that format that we're familiar to. C, because it doesn't define its integer, it's not complete. And D, because it doesn't give X a data type, it's also not complete. So let's get into more coding questions. So we have a variable. How do we get the memory address of a variable? Yes, and. So if you're not familiar, the and sign is a memory operator. And what it does is it takes a variable and tells you where in memory that variable is stored. Now, why might it be useful for you to know where in memory a variable is stored? Well, we have pointers, and pointers, they store the memory address of the variable that they're pointing to. So by using the and sign, the ampersand, you're able to get the memory address of a variable that we want to store. So the next question is then, how do you allocate memory in C? All right, so there are a few functions we have to allocate memory. One of those functions is malloc, and the other one is calloc. So we have two functions, so that means there must be some difference between the two, otherwise there would only be one. Do we know what the differences between these two functions might be? Yes? Excellent. Yeah, so imagine this block here was the memory that we wanted to allocate. If we used malloc, we're actually not sure of what might be stored in this block of memory. But if we used calloc to do the exact same thing, calloc would actually set that memory location to all zeros. Why is that useful? It's useful so that you know the memory that you have available to you has a set value. It's not random and you know what's there. So it's like a good starting point to use calloc because you know everything is going to be zeroed out. Another difference between the two functions is how their arguments work. So malloc takes one parameter, and that's how big of a space you want it to take up. Calloc takes two parameters, takes how much space you want, comma, and then how big is each space that you're going to allocate. So what that looks like for calloc, so we're going to allocate 10 spaces using both functions. So for malloc, we can say 10 times, let's say, the size of an integer. So size of is a function that you will see used with malloc and calloc because it lets you figure out the size of the data type you want to use. But calloc is simply 10, comma, size of int. So it's important to know the difference between using the two and also the difference between the result of the two functions. So we were talking a little bit earlier about pointers. How familiar with structs is everyone? Well, a struct is a way of grouping different things together in one form. Why is that useful? Well, it makes your code easier to read if you had a struct to represent something. So structs could represent an idea, it could represent a thing or an object, but structs make using that idea a lot easier. So let's say I have a struct called dog. So dogs tend to have names, so I'll give it a name. And let's say dogs also have an age. All right. The usefulness of a struct is it lets us pair up these ideas together under one concept. So in this case, we have an array and we have an integer, but they're bundled together and we call it a dog. So that's the usefulness of a struct, is it lets you take an idea and give it a form in your code. So for question 7 then, now that you have a struct, how do we use the struct? So for age, for example, how would we get the age of our dog that is a struct? Well, let me create a dog variable. So let's say we have struct dog. What should this dog be called? You know, I'll call it Danny. So we have a struct dog Danny. If I wanted to get Danny's age, how would I access Danny's age? Yes. Danny.age. So with structs, to access the members inside of that struct, you can use the dot operator. So you would say the name of your struct variable dot the name of the variable inside that struct you wanted to use. But what if instead of a normal struct, we had a struct pointer? So pointer denoted with the asterisk. If Danny was a pointer instead of a normal variable, accessing is a little different. So if Danny was a pointer, we would use a hyphen followed by a greater than sign and then age. So that's a difference to keep in mind with structs. Whether or not it's a pointer changes how you access the values inside of it. Any questions? All right, so let's see then, can we write a program that checks whether or not a number is a multiple of 3 or a multiple of 7? So to accomplish something like this, what might we need to know or need to use? Yes, modulus. So how is modulus useful for something like this? Yeah. Yeah, so this is also a property of numbers that modulus is very useful for. So before we said that if a number modulus 2 was 0 or 1, that tells you whether or not it's even. That also tells you whether or not it's a multiple of 2. So if we wanted to find multiples of 3, we would say check if this number is if that number modulus 3 is what? What would that value have to be for it to be a multiple? 0. Because if you were truly a multiple of a number, then you shouldn't have a remainder when you use the modulus operation. So let's write a program then that tells us whether or not our number is a multiple of 3. So I will just write a segment. So let's say if, let's have a number x, if x modulus 3 equals 0, then x is a multiple. And it translates that if we wanted to find if x is a multiple of 7, it's a very similar line of code. X modulus 7 equals 0, then x is a multiple. All right. So this first one, good example of the usage of modulus in a program. Question 2 is, how would we write a program that takes two numbers and tells us which one of these two numbers is closer to 100? So there are a few things to think about for a program like this. Is how do we determine how close two numbers are to another number? How close is 3 to 10? What was that? What? You would use, I got confused, sorry. My question was, how far is 3 from 10? 7. How did you calculate that? Subtraction. So given that you have two numbers, if you wanted to determine how close they are to 100, you can subtract that number from 100, and whatever number that is tells you how close it is to 7. So let's see, we have a number x and we have a number y. So let's say x is 80, y is 101. Which one of these is closer to 100? Y. But in order to figure that out, we could say if 100 minus x, and then compare that to 100 minus y. There's a problem here. I don't know if anyone sees it, but there is a problem, but we'll continue with it as it is. So we take this value and we compare it to this value. So how do we perform the comparison? What are we looking for? A big number or a small number? Smaller number. So whether or not 100 minus x is a bigger or smaller number than 100 minus y, that'll tell us which one is closer. X in this example is 20 units away from 100. Y in this example is only 1. So we want to check whether or not x is less than, whether or not 100 minus x is less than 100 minus y. The issue arises in both of these scenarios when the number you want to subtract is bigger than the number that you're checking. So how do you overcome that? Absolute value. In this case, I would recommend putting an absolute value before both of these. So no matter what the operation is, you would get one whole number instead of negatives. Because let's say, for example, y instead of being 101 was 110. Actually, 130. So we took 100 and minus 130. This would give us negative 30 as a value. And negative 30 is a whole lot less than 20. So our program might think that y is closer to 100, but it's not. So it's important to know that you can use absolute value in a situation like this so that you don't go past the range of numbers you want to check. So 3 is not as long of a program as you might think. But how do you convert a string to an integer? A to I? So I want to say to you guys to look at the libraries that you have access to, because there's a lot of cool functions that you might not even know is available to you. So strings are a little weird in C because of the fact that they're represented like arrays, right? But in the string.h, there are a few functions that are very useful. One of those is A to I. This A to I function, it will take a string and give you the integer value of that string. So question 3 is actually a short program to write. What makes it difficult is whether or not you knew you had this function available to you. The alternative is a lot longer than that function call. So remember that you do have functions available to you, so keep in mind which ones are useful for which application. In the previous question, we found absolute value to be a useful function. Question 4, take the hours and a minute and calculate the number of seconds of that time. So if we had 3 hours and 23 minutes, how many seconds is that? Yes, it is. It is quite a lot. But how would you figure it out? How would you calculate that? Okay. Yeah. So what is the conversion between minutes to seconds? How many seconds are in a minute, I should say? 60. There are 60 seconds in a minute. How many minutes are in an hour? 60. Very convenient set. So 60 times 60. So every hour has 3,600 seconds. Every minute has 60 seconds. So to figure out the amount of seconds given hours and minutes, you can take the amount of hours, multiply that by 360, take the number of minutes, and multiply that by 60. Oops. You add these two values together, that'll give you the total amount of seconds. So this problem is more of an exercise of knowing that you had that as an option, figuring out how to take one value, convert it to another. You could easily do this in a C program. Question 5 is a very fundamental question. How do you find the largest of 3 numbers? Oh, that is actually a really nice thing you said there. So if you had your 3 numbers in an array, if you used bubble sort on that array, the last number would be the largest number. Very good insight. That's actually how things like this is done quite often, is you could just sort your numbers and then that would figure it out for you. Are there any other ways you could figure out the largest of 3 numbers? Yeah, excellent. You could just do a series of comparisons to determine whether or not a number is larger than the other. So let's just look at an example of what that might look like. So let's have 3 numbers, A, B, and C, and we want to find out which one of these is the largest. Now, there's a whole set of ways you can accomplish this. The quickest way, I would say, is with 3 if statements. So these 3 if statements could be written such as this. If A is greater than B and A is greater than C, what's our conclusion? Well, A is the largest number. What about the other ones? Well, we have the same idea. We check if B is greater than A and is B greater than C. If B is greater than C and A, then we know that B is the largest. And the same comparison can be done with C. You'd only need 3 if statements. Technically, once we've checked A and B, the only other option would be an else. We could just say else C. But you can have this as a nested if statement. You could have this using the bubble sort to sort it. But knowing how to find the largest value given a set of values is a good skill to have. So let's see. 6 is a bit more involved, so it's more of a mental exercise. But how do you print the reverse of a string? So if we had hello world as a string, how do we get I don't even know how to say it backwards, but you get my point. How would you print that out backwards? What might you do? Excellent, yeah. It surprises me how often people forget that your loops don't have to go ascending. You can loop descending as well. So to print a string in reverse, we can simply start at the end and go towards the front. And that takes care of printing a string in reverse. Nice program. 7 is another problem related to strings, and that problem is how do we find the character that occurs the most frequent character. So if you were looking at a word, how would you know which letter happened the most often? That's exactly right. You count how many times that letter shows up. How would you count that in a program? That is the essence of this problem, is how do you count every single letter? How would you count every single letter? Yes. You keep counting until you reach the end of the string. Excellent. How would you keep track of how many letters you have for each letter? Like how many A's do I have? How many B's do I have? How would you keep track of all of that? Yes. Yeah, excellent. Does everyone know what she means by that? This is commonly known as a frequency table. So if you have a list of numbers or a list of characters, you can use an array to represent every single one of those values. So our array, starting from element 0 to element 25, that will represent our letters from A to B, from A to Z, right? So every time you see an A or a B or anything, you simply go to that position in the array and you add 1 to that spot. That way, at the very end, all you'd have to do to figure out which letter occurs the most often is just to go through your array and see which element has the most values. So let's see if I have an example of that. Excuse me? Homework 8. Yes, yes it did. I just want to show everyone how that looks like in code. So we need an array to represent our letters. So I'm just going to have array alpha. It's going to have 26 elements to it. Now we need some string that we want to check. So I'm just going to create a string. Let's give it 100. What I will store in here will be hello world. All right. Now let's count how many characters for every character is in here. So I'm going to use a for loop for something like this. Let me have my variable x, variable element. So we will have element equals 0, element is less than 26, element plus plus. All right, so how do we actually do the counting? Well, we will take our string at the current element, and that will give us a value. That will be an alpha numerical value, but we want to get a value that's in the range 0 to 25. So something to always remember when using characters and strings is the fact that there's an Ascii table. So what is the Ascii table? The Ascii table is a chart that relates every character to a value. And it turns out that you can use characters themselves to perform math. So if I were to say string minus a, for example, that would give me a value in the range of 0 to 26, or 0 to 25, I should say. Why does this work? Well, let's take a look at some values in the Ascii table. So what I always try to remember about the Ascii table is that lowercase a, I believe, is 65. Actually, it's 97. Lowercase a is 97, and uppercase a is 65. So there's always going to be some value attributed to every character through the Ascii table. This is useful because let's say my string at element 0, for example, that string value was an h. I believe h has a value of, let's see, 103, I believe. So with what we know about characters and their values, we can take this 103, subtract from it the value of a, and we will get a value that's in between 0 and 25. So that's how we will know where in the array to put our value. So I'm going to go to our array. I will say alpha, and the element I want to change is the element whose value is string at the current element minus a. Now I'll just say plus plus. Now that element will have its value incremented. Now we'll do one more thing, and that's this. Does anyone know why in line 4 I set it equal to 0 in this way? Excellent, yeah. So this is a fast and easy way to set your array all to zeros, would just to use your initialization list with a single 0. and it will set everything else to 0. All right, so I believe we have everything we need. Now we just want to print out our array. So again, I'll use for loop. I will just copy what I have here. And what I will print out instead will be this. Printf, and I will say %C, colon, space, %D, \n. What I will pass into it will be element plus the value of A, and then I also pass into it alpha at that element. Believe everything, compile, no issues. All right. So we look at the output. It's counted how many of each character that it found. So it found 2 A's, it found 4 L's. So this method is very commonly used to find frequencies of letters. You have an array to store the frequencies themselves, and to find the most frequent, you simply look through the array and see the element with the largest value. And in this case, L is the most occurring letter in this string. Now you can use a frequency table for all sorts of different applications. It's just important to know how to use the array to represent your values. So let's say you had an alphabet that was bigger than 25 letters. Then you would adjust your array accordingly and keep in mind how each element translates to a value that you're looking to count. All right, so let's see. One more. All right. So 8, the last question is a fun question. It's funny how recursion always comes back to you. So question 8 is, how would you use recursion to find the sum of the numbers from 1 to n? Well, remember, recursion always has 2 things. It has a base case, and it has a way of reaching that base case. So if you're counting all the numbers from 1 to n, what might your base case be? 1. Base case is the case where you're counting from 1 to 1, and that value is just 1. So base case is n is equal to 1. All right? So how do I then go from where I'm currently to this base case? So that, the recursive step, is a little something like this. You take n and you add it with the sum of n minus 1. So sum is this recursive function that we want to write, and eventually we want it to give to us the sum of the numbers in a range. So I will show you this program. All right. Let's see if I can just go back. All right. So I'm going to write our function prototype. It will be in, yes, it'll be an integer, sum, and it takes one parameter, and that parameter will be n. All right, so what I'm going to say is printf okay, %d and sum of 10. All right, so let's write the sum function. Int sum. Okay. I see. Excuse me, this computer it's a little old. All right. So our base case is if n is equal to 1, let's return 1. All right. Otherwise, I want it to return please. N plus the sum of n minus 1. All right, let's see if we get a value. I have a missing parentheses. All right. I don't know if this is correct because I haven't counted it, but I'm assuming it's correct. It's telling me that the sum of the first 10 numbers is 55. So I just want to verify that really quickly. So 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21, plus 7 is 28, plus 8 is 36, plus 9 is 45, plus 10. That is indeed 55. All right. So how do you come up with this solution? It's always thinking to yourself, what is the base case of my problem? And how do I go from my current problem to the base case? So your current problem is going to be the number that you passed in, which in this case was 10. So you want to think to yourself, how do I get from 10 to my base case? Well, the sum of the first 10 numbers turns out to be 10 plus the sum of the first 9 numbers. The sum of the first 9 numbers tends to be 9 plus the sum of the first 8 numbers. So the recursive step will always follow a similar pattern of finding your base case and figuring out how to get to your base case. All right, so I just want to remind everyone of a few things. There should be an evaluation form. I don't know if everyone's got one. Does anyone need the evaluation form? Is there a packet of them anywhere? No? All right, let me give you guys a few. If you don't mind just passing them around, please fill them out. It gives us helpful feedback on SI and ways that we can improve. So what I want to talk about now is then, how are we going to continue to study for this final? So I just want to go down the line and just ask everyone what their study plan is. If anyone wants to volunteer, but I'll just go in order. So up here, how are we planning to continue studying for the final?
Try to practice more.
Excellent. Practice makes perfect. Practice is a great way to get better at programming. It's really through practice that you just feel what you need to do, and you just get used to using the tools that you have.
I'll just review some of the chapter PowerPoints.
Excellent.
Some examples.
Excellent. Yeah. So the notes that you receive in class they're useful for a reason. So always look back at your notes more than once. You might catch something that you didn't before. Something might click the second time around if it didn't the first time. So over here, how are we going to continue to study for this exam?
Practice on the textbook questions.
Excellent. The textbook is written by really knowledgeable people who are writing the paper that is explaining to you everything. So the textbook's definitely a great resource. There are practice problems. There are examples. So the textbook's a great resource.
I was planning to do the practice test that the professor provided.
Yeah, excellent. Doing the practice test. Refer back to your notes when doing the practice test. Refer back to previous code you've written when doing the practice test. Because now at this stage, you've written quite a few programs. So you are one of your best resources for how to write a program. Yes.
I was going to do the practice test and then reading the chapter summaries.
Excellent. How many chapters do you have to read? Just curious. Do you know? 2? No, how many topics do you plan on covering while you're...
All of them that are independent.
Yeah. I was just seeing like maybe there's one section you're going to focus more on than another section. But no, general studying is great too. What about you? Excellent. Yeah. So practice is really going to drill into you how to do these programs. It's also going to get you used to, as I said before, the concepts that you're using. And if you do want practice outside of your textbook practice problems, outside of your professor practice problems, there are tons of websites that also have practice problems that range in difficulty. So you can do an easy problem, you can do a hard problem. You can do problems with different categories. So if you're looking for practice, there's lots of resources available to you to get that practice.
I was going to do practice tests, watch videos.
Excellent. Old homework problems. So that's a new one I heard, YouTube videos. How many of you have watched YouTube video on programming this semester? Excellent. They are really nice. They're not, how I should say, fast-paced like your lecture. You can take your time on a YouTube video, and some of them go into really good depth of the content, and they code, and they explain what they're doing. So look into YouTube videos, not only for this final, but for future programming that you might have issues with. There are tons of YouTube channels that are great. My favorite one is called New Boston. When I was first learning C programming, I watched pretty much all of his videos. So I recommend New Boston.
I'll be reading at the end of the textbook and summaries and
Mhm.
reading that, and then also just doing practice problems and the practice exam.
Excellent.
About the same.
Same thing? Reading slides. Yes.
It says please bubble the number at the top of the thing.
I don't believe that's something you have to worry about. Yeah. Yeah, if you're finished with the evals, feel free to pass them forward. Are there any questions? We still have a few minutes, so this would be a good floor to ask questions, get some answers. Any questions at all? I'm right here. Anonymous.
Like the PDF or whatever you're scrolling through, is that available to us?
Yeah, if you go to the, let's see, UCF Study Union .wordpress.com. It's a website created just for the study union. If you go to the computer science section and you scroll down to my bit right here, the Intro to C Final Review Part 1, that was what we were scrolling through. This has some practice problems if you want to try writing those codes on your own. And not only is my review information available, but the information of all the other SI leaders is also available here. So if you want to cross-reference our review slides, all that information is here. If you want to relive this moment with me, it will be recorded and available to you guys. So look out for that, as well as for the other SI leaders. All that is available to you guys. Yeah, no problem. I wish all of you the best of luck on your finals, and particularly this final. There's not a part 2. I'm leaving part 2 up to you guys. I just wanted to cover the basics during this time, namely because the later topics are more involved and will just take up more time per topic. But I'm sure you guys are all well off to solve those. So practice makes perfect. So